Hello everyone, welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and I have a very compact video for you today. A video where we are going to be discussing and understanding everything as it relates to transformation geometry, but specifically we're going to be looking at reflection. Now, of course, in our previous video, which I will have a link pinned in the comments or in the description box below, we had a very elaborate discussion on the topic of translation. So definitely do check that video out before coming on to this one, if it is that you need a thorough understanding of what a translation is. So we're going to be shifting our focus now to a different type of transformation. And this type of transformation here, unlike translation, where the object moves onto its image in the form of an L, or it basically slides and glides along the X and Y axis, this particular transformation, we are going to be flipping the object over an imaginary line. But before we get into the actual discussion of this particular video, please be sure to hit the subscribe button below if this is the first time here on the channel. Do not forget to turn on your post notification bell to be notified daily and weekly for tutorial videos that will help you in preparation for your upcoming exams or just in general, the topic itself. Do not forget to hit the like button. It really does help the channel to grow and helps the channel to go onto the YouTube algorithm. And of course, leave some positive questions and comments down below. I would love to hear your thoughts about how you're feeling as it relates to the topic. Now, at the end of this video, the objective is not only for you to understand what reflection is, but you are going to learn to apply the concept of reflection on the graph. You're going to also apply the concept of reflection in real life, and we're going to also go ahead and do some very cheeky calculations. So hopefully at the end of this video, you would have solved your problem when it comes to the reflection, the topic of reflection. All right, so without further ado, let's jump right into today's lesson. Alright guys, so I'm going to be walking you through some theoretical explanation of what is a reflection, what is a mirror line, and all these little important fundamental details. Many times students find graphical topics challenging because the foundation around the topic is not well set. So we need to set that foundation so as to prepare for what's coming in this video. So what we're looking at here is, first of all, what is a reflection? And so a very simple layman's definition of a reflection is that a reflection is a movement, or reflection is the movement of an object, which we already discussed can be a shape, it can be a point, it can be 2 points, or it can just be particularly a series of points that forms some sort of shape. So there we're going to be moving the object onto its image, but we're going to be folding, or so to speak, we're going to be flipping the object over what is known as an imaginary mirror line. Now, this line is imaginary because most times you are going to be the one that's going to be drawing the mirror line. There are some standard mirror lines that are already on the Cartesian plane. For example, the x-axis will serve as a mirror line, the y-axis will serve as a mirror line, and of course we have the two diagonal lines, which is the lines that we call y equal x and y equal negative x. We will discuss that further in the video. Now, what exactly is a mirror line? So of course, the mirror line is an imaginary line that basically it's the midpoint, well, it marks the midpoint distance between where the object is located and where the image is located. So this line pretty much tells us the middle distance. For example, if we have a point on the Cartesian plane that is at a specific location and its image is at a specific location somewhere on the Cartesian coordinate system, then of course we're going to be counting the distance between where the object is located and where the image is located and divide that distance in two. So therefore the mirror line, which could be vertical, horizontal or diagonal, will be going through that particular value on that axis. Now there are infinitely many mirror lines that can be constructed on the Cartesian plane, but there are in fact some very standard mirror lines that already exist, and that's what I had mentioned earlier, where we have, for example, here the x and y axis are mirror lines, and we have the diagonal lines y equal x and y equal negative x. Now let's dive a little bit into what exactly is a reflection. Let us look at some graphical demonstrations here. Now what I have on screen here are some diagrams, images that I got, of course, from Google, that I find very useful in helping you students to understand more about what a reflection is. So basically here I have the 4 standard reflections on screen. And so for diagram 1 over here, where you're looking at, say here, this particular line that is point A connected to point B, we have this line that undergoes a reflection across the x-axis. And so we can confirm that this is in fact a x-axis reflection because the object basically jumps from the top and goes at the bottom. So basically a x-axis reflection is, so to speak, or for argument purpose, for conversational purposes, it's a vertical reflection. So therefore it jumps from top to bottom, or it jumps from bottom to top. Now, just to give you a premature exposure to what the mirror line really is, if you notice very carefully here that because the x-axis is the mirror line, notice that point A here is actually 2 units above this particular line here. So notice now that the image of A, which is below here, is also 2 units below. So you see here that it is 2 units away from the x-axis above. So it's going to be 2 units away from the y-axis below. And again, for point B here, you'll realize that it is 1, 2, 3, 4 units away from the x-axis. So that's going to be 4 units away from the x-axis. So therefore, it's going to be 4 units below the x-axis for the reflection of that line. Now, moving on then to the y-axis reflection here is where you're seeing that the object is going to be what is referred to as a horizontal reflection. So basically then you're going to find that the object jumps from left side of the graph to the right side of the graph, or the right side of the graph to the left side of the graph. So the comparison is going to be made in relationship to the y-axis. So you'll notice here that the point A here is actually 1 unit away from the y-axis. So therefore, on the other side, it's going to be, say here, 1 unit away from the y-axis on the other side. And so of course here you realize that B is also 1, 2, 3, 4 units away from the y-axis, that is here. And so therefore B prime is going to be 4 units on the opposite side of that particular mirror line. So that's basically the graphical understanding of a reflection across the x-axis and a reflection across the y-axis. Now, we are therefore looking into these diagonal reflections, and these types of reflections are a little bit more challenging to understand visually. It is not a case where it's easy for you to say the points are this amount of distance from the line. It can be a little tricky depending on the object. Now, it can be done, but there's always means and ways around it. Let's just move this graph here over to this side so I can see y equal x. And there we go. All right, so now we're looking at the line y equal x. And so the line y equal x, what I always encourage my students to do is that sometimes students will oftentimes make an error in terms of which line is which line. So y equal x and y equal negative x. So basically then, I always tell my students that the line y equal x runs through the odd quadrants. So that means y equal x will run through the vertex of the squares in quadrant 1, and it continues through the origin and it goes all the way down, which you're not seeing in this video here, this image here, but it goes all the way down to quadrant number 3. For the purpose of this video, I'm kind of focusing on the actual line of reflection here. So we're not extending it below to the other part of the Cartesian plane. So here we're looking at this line here. Normally you can put up your left hand as if you're going to throw a fist, and your left hand automatically will tell you the direction that the line y equal x is traveling. So basically then, here we have the point A, B, and C forming a triangle, okay? And so for demonstration purposes here, just a premature demonstration before we actually dive into the real aspect of reflection. Here you're looking at the point B being on the left side of this diagonal. Now it looks like it's about a half a square on the left, so automatically it's going to be, say, a half a square on the other side here. And so therefore then we can look at C being, say, here 1, so this is going to be 1 full square, so 1.5 square on the left side of this mirror line, so it's going to be a half and 1 square here on the right side of this line. So this is going to be my A prime, this is going to be my C prime, pardon me, this is going to be my C prime. And then of course you'll recognize here that it's a little difficult to really estimate what A is because this diagram is shaded. But if I'm going to make a guess here, I'm going to say that it's going to be 1, I'm going to say 2, I'm going to say 2.5. Okay, if I'm going to make an educated guess, it's going to be about 2.5 squares from the left side of this mirror line. So it's going to be a half, 1, 2 squares here on this side here. That's going to be my A. Okay, this is actually my A prime, pardon me guys, and this is actually my B prime. So if I were to perhaps say connect this point here to say here, this point here to this point here, we're going to get an image reflection of that particular point. All right, so it can be done this way, but I find it a little bit more challenging, especially if the diagram is really running across those, what I would call, it's basically running across the squares, not necessarily right in the halfway point. So it can be a little tricky. If that works for you, then okay, no problem. Now, for the line y equal negative x, then you'll realize that the line is running in the opposite direction. That is, it's running through the even quadrants, meaning that it's running through quadrant number 2 and quadrant number 4. Okay, so therefore then same procedure. A here is going to be 1 full square, so 1.5 squares from that mirror line, so a half and 1. A should be somewhere up here, so that's going to be my A prime here. And so B is going to be a half a square away from the mirror line, so it's going to be half a square on the other side, so that's going to be, say here, B prime. And C here, just to guess, educated guess here, it's going to be 1, say here, 2.5 squares from that mirror line, so it's going to be a half and 1, 2 here on that side. That's going to be my C prime. And so of course, if I were to, like, say here, connect those 2 points here and then connect C prime to, say here, B prime, and then connect A prime here to B prime, I will get the reflection of ABC on the diagonal. So if that type of method work for you, if the particular question to which you're asked doesn't necessarily require the calculation, then you can actually use the graphical approach to this. But we're going to dive off a little bit more into the calculation and these kind of methods a bit later in the video. So of course, already, if you have not hit the like button and you're already enjoying the content, please do not forget to hit the like button. It really does help the channel to grow, guys. So let's get right into it and continue. Now we're going to go across to the next slide here, and then of course we're going to be learning how to actually construct the diagonal mirror lines, because a lot of the times you don't necessarily need to draw the line, the diagonal lines. We just kind of use the calculation. But there are certain situations, there have been questions on CSEC where CSEC, or depending on the course that you're doing, or if you're doing the topic of transformation geometry, at whatever level math that you're at, this video applies to you. Sometimes drawing the diagonal, you'll find that a student just gets up and they'll do something like, say here, this, draw the line anyhow, or they'll do something like, say here, this, and draw the line anyhow. They just want it to go through the center. And so here that's going to be incorrect, because to draw the diagonal lines, it's not about going through the center, because of course the line can actually rotate. So you can have several lines going through the center. Okay, you can have lines going through the center like so here. I can have lines going through the center like so here. Okay, so it can basically rotate around the origin. Now, to specifically get the line y equal x and y equal negative x, here is that it has to go through the vertex of the squares that you're seeing here. Specifically, it has to go exactly through the squares here. So here and here. Okay, so all you need then is perhaps 3 points or so. You don't need 3, perhaps just 2. Let's just use 2. You can just use 1 here and say here, just run your pencil in this direction. Follow me carefully, guys, and have another one up here. Okay, you can have it like that. So 1 2 3, okay, right here. Okay, that's on that side, and then we can have it here on, say, this side here, and just follow in that diagonal direction. Don't veer off to the left or to the right. Just keep it in this line here and here and here, and we can put another one, say here, down here. Okay, and then of course we can use our ruler then, and we can connect this line here all the way to that one here, and then we can connect this one here all the way through to that one down here. And then what you're going to be having there is the perfect line y equal, in this case here, y is equal to x. So this is how you actually construct the diagonal mirror line. It's not about just drawing it through the origin. It's drawing it through the origin and having it touch the vertex of the unit squares here. All right. Now, of course, same procedure for y equal negative x. We're going to pick a vertex point here on that square. Okay. So put a vertex point here, and then just follow in that same straight line here. Following that same straight line here, down here, and let's put a point down here. That's also fine. Okay, and then we're going to go ahead and put a vertex point here, and then just follow in this line here and drop another one up here, just to make sure that it is straight. All right, and then we do the same procedure. Then we're going to just connect this one here through the vertex. Make sure it goes through the vertex, guys. Okay, so gonna just be careful. We have a ruler. I don't have a ruler with me now, so gonna be a little bit tricky for me. All right, and then just come through the center, go through that point, comes through all the vertex of those unit squares, and come down to that one. And so basically what we've just constructed here is our line y equal negative x. And you can just go back to the previous slide where you also see that it's the exact same thing that was being done here. Notice that it starts from the origin here and it went through here, through here. Notice that the line perfectly goes through these vertex of these square unit squares here. Same thing for here. It goes through here, and it goes through here, and it goes through here, 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 and here. All right, so that's basically how you construct that line. So in the event that Csec or your examination asks you to draw the line y equal x or y equal negative x, ensure that you know that it goes through the vertex of those unit squares. It would be nice if you actually have a graph at hand while you're watching this video, so you can actually go ahead and pause the video and do your construction. All right, beautiful. Now let's scroll down to this slide down here where we're looking at what is known as the reflection formula. Now, many instructors have different ways of teaching this. This particular video is going to be covering both methods. The methods where you have to remember what exactly happens to the points through the reflection, as well as I'm going to be showing you how to use, as you're seeing here on screen, the reflection formula. So the reflection formula, just like the rotation formula or the enlargement formula, you're going to have the transformation matrix. In fact, before we get specific, the formula for, apart from translation, the formula for reflection, rotation, and enlargement is going to be, say here, the transformation matrix, okay, multiplied by your object point is going to always produce your image point. Okay, so that is the general, let's just put a marker around this. This is the general formula for reflection, for rotation, and for enlargement. Now when it comes to reflection, we're going to specifically say the reflection matrix. So it's going to be the reflection matrix multiplied by the object point that is equal to your image. Okay, so that's basically what we're looking at here. Let's create some space here. Let's just transfer this on the graph up here. So let's just keep our general formula in the corner here. That is transformation matrix multiplied by, say here, object point will give us our image point. Let's just put a little marker around it. This is our standard formula for all transformations. There we have it here, guys. Okay, beautiful. All right, so then now that we have an understanding of what this is, then let us look at what exactly is the reflection matrix. Now, of course, for some of you guys may have seen the topic of matrices. I have not yet gone to that era of math on my channel where we have matrices topics, so I do not have a recommended video for you. But if you have knowledge of matrices and how to add entries in matrices, then that little bit of knowledge will give you an advantage in this tutorial. But if not, let me just guide you as best as I can through this. Now, what exactly is the reflection matrix and how do we actually obtain this particular matrix? Let's first understand that the reflection matrix is a 2 by 2 matrix. What does 2 by 2 mean? It means that this matrix has 2 rows and 2 columns. So it's going to look something more like A, B, C, D. So it has 2 rows, that's row 1, row 2, and it has 2 columns, column 1, column 2. All right, so it's a 2 by 2 matrix, but specifically it's consisting of combinations of ones and zeros. So you might have a matrix that says 1 0 0 1 or minus 1 0 0 minus 1 or 1 minus, or you might have 0 minus 1 minus 1 0. It really kind of depends on what is it that you are doing. Now, there are 4 standard reflections which we all have distinct matrix, but the challenge is understanding the change after the transformation. Many students find a challenge in remembering what happens to the coordinates of the image under a reflection in the x-axis, or what happens to the coordinates of the image under a reflection in the y-axis, so on and so forth. So I'm hoping that I'm going to be able to give you an easy way to remember this. All right, now here we're looking at a reflection across the x-axis. Then we have, of course, a reflection across the y-axis. Then we have a reflection across the line y equal x, and we have a reflection across the line y equal say here down at the bottom, negative x. Okay, so how do we obtain this particular matrix? First of all, you're going to need to remember exactly what happens to the points. Now, I've saved this little space here for you so we can work this out. Now, let's say that we have a random point, which we know is always written in the form x, comma, y. I'm going to therefore then just write this in column form. So I'm going to have x, y, right? And so xy is going to be sent through a reflection across, say here, the x-axis. What happens to the points after it gets reflected is that the x coordinate is going to remain what it is, but the y coordinate is going to change. And so we have to specifically say the word change, because many times I find that students will often think that it changes to negative. It doesn't necessarily change to negative, but it actually changes sign. That means depending on the combination of that random point, whether it be negative, negative, or negative, positive, then it will change to the opposite sign. Now, once you understand that a random point undergoes a reflection in the x-axis will have the y coordinate changing, then what we usually do here is that we then split this up into a 2 by 2 matrix. So what we do here is that we say there is one x at the top, okay, one x at the top, and there is no y at the top, so it becomes 0y. Okay, so we're just focusing here like so. All right, so therefore then we're looking at, oops, here we go. So at the top there is no x, sorry, there's one x and there is no y at the top, but at the bottom then you realize that there is no x at the bottom, but there's a negative y, which means that there's a negative 1 here at the bottom. So this then represents our reflection matrix across the x-axis. All right, that is how you transition from a random point to the change in the point to the change in the matrix. Okay, let's just then move on then to looking at, say here, example 2. So now we have, say here, a random point. And so for this random point xy, I'm going to write it in column form, it's going to be sent through a reflection across the, say here now, y-axis. So what usually happens here is that we get the exact opposite layout, where in this case here the sign of the x is going to, say here, change, but the y value is going to remain. And so again we can transition from this then and ask the question, how many x's are at the top of this matrix? Then we realize that there's one x at the top of this matrix, but there is no y at the top. And then of course at the bottom of this matrix we have no x. It's always asking x then y, x then y. So how many x's are at the bottom? There is no x at the bottom. Then we have, say here, one y at the bottom. So now we have another combination matrix here. This time it is -1, 0, 0, -1. So if you're actually in the exam and let's say you get a question that say, what is the reflection matrix for an x-axis or y-axis or y equal x or y equal negative x, your task is to always remember the change. If you don't remember the change, if you don't remember that in the x-axis the x will remain and the y will change, or in the y-axis the x will change and the y will remain, then of course you're going to find a challenge in transitioning to the matrix. Now it kind of depends on you, because for me over time as I'm teaching this topic, I tend to be able to remember these combinations of ones and zeros for the reflection. What happens later on now is when you learn rotation then, and you learn some more other ones and zeros combinations, then it becomes a very blurry concept. And so with that blurry concept, especially if you're under exam preparation pressure, you're going to get them sometimes confused. So it's very important that you take the time out to study the actual change that occurs from the random object point to its image under each reflection. Okay, let's then move on then to say here another example. We're going to be looking at, say here, the line y equal x. So again, we have a random point here, say xy, and it's going to be sent through the line of reflection y equal x. So what usually happens here is that you're going to find that the random point xy is going to interchange position. So the x is going to go where the y was, and the y will go where the x was. And so therefore we have an interchange in the position of the ordinate values. So basically we see that x and y interchanges position. And then of course we can transition then from this change to the metric. So to get the metric here, we ask ourselves again how many x's are at the top. In this case, there is no x at the top, so that's 0. And then how many y's are at the top? Clearly there's only one y at the top. And then at the bottom now we ask ourselves again how many x's are at the bottom. Then we have, say here, 1x at the bottom. And how many y's are at the bottom? There's obviously no y's at the bottom. So this then gives us our reflection metric for a point being reflected across the line y equal x here. All right, so hopefully you guys are following the change that is occurring here. Guys, remember that you have to spend time to know the change that occurs in each point. If you are not practicing or if you're not remembering, then there's aspects of math later on that's going to give you a challenge. So this video is geared towards helping you to understand reflection, but I'm not sure if I have a technique for you to, or a formula for you to remember the change. That pretty much will be your responsibility. So the last one here then is, again, if I have a random point here, say here xy, if I have a random point here, say xy, then again, once it goes through, in this case here, it goes through the line y equal -x, then you're going to find easily then that here, say, we are going to interchange the positions of the ordinate values, but we are also going to change the signs. Again, guys, remember that we do not change the signs necessarily to negative. We simply change the sign. So whatever combination of that random point, whether it be negative, positive, negative, negative, or positive, positive, then whatever sign the ordinate values currently have will change to the opposite sign. So plus becomes minus, minus becomes plus, so on and so forth. And once again, we can transition from the change to the metric here. We are again at the top. How many x's? 0. How many y's? These are negatives, so that means -1y here. And at the bottom, how many x's? -1 here. And of course, here, see at the bottom, how many y's? 0. All right. Now, earlier in my studies, I recognized that these last two reflections are pretty much a combination of what is known as a reflection across the origin. Now, you don't find a lot of instructors talking about a reflection across the origin, but the reflection across the line y equal x and y equal -x is basically a combination of a reflection across the origin. Okay, so a reflection across the origin, later on during the tutorials, you're going to find that a reflection across the origin is basically like a rotation of 180 degrees about the origin point 0, 0. But we're not going to go too much in depth. We just want to keep it surface level, keep it very simple for you guys to understand. Now, here, say, as we already discussed, those are the combinations of the, say here, reflection metric. All right, now earlier I had demonstrated to you how to actually reflect an object without the formula, simply by just moving equal distance away from the mirror line. That was in this particular slide. Remember that this slide here where we started off, let's see here, we started off with, say here, this slide. Okay, so in this part of the video here, where I was showing you that we could jump across equal distance, that's what we're going to be discussing now in this aspect of the video. So we're going to be looking at general reflection without a formula. All right, now as discussed, a reflection is where the object is mapped onto its image across an imaginary mirror line, or say an overlapping line of symmetry. So basically it's a line that cuts the distance between the object and the image into two halves. Now this marks the middle distance between the object and the image, and let us kind of demonstrate with this example here. Let us demonstrate how exactly we can actually reflect this object without, say here, a standard reflection. So this time now we're not going to be reflecting it across the x-axis per se, or say the y-axis per se, or let's say the line y equal x or the line y equal negative x. It can be literally anything. So the higher level that you go in transformation, you're going to find then that you're going to have different types of reflection lines. Now I will have an advanced tutorial that I will post maybe a few weeks from now when it comes to for college students, transformation for college students. So if you definitely are watching this video and you're a college student wanting to learn more in-depth knowledge about transformation, leave your thoughts and comments down below, and I'll definitely get to that soon, very soon. But for Csec students or students at the secondary level, high school level, grade 11, grade 10, perhaps say grade 13, then you're going to find that we're going to keep it very simple here. All right, now let us go ahead then and exercise our skill set of plotting points. So let's just use here a white marker, and so we're looking at plotting the points. It says, let's read the question first. It says, given the points A is -1, 5, B is 2, -2, and C is -3, -1, undergoes a reflection in the line, say here x equal 3, say here y equal -2, say here x equal -2, and say here y equal 1. So of course we're going to be reflecting this particular, say here, shape that is going to be formed across these non-standard mirror lines. This section of the video here is where we're going to be calling this non-standard reflection. All right, so let's go ahead and start by plotting our points, and ensure that you guys have a graph with me, working with me as well. It would be nice for you to be watching the video and be pausing, doing it, and then matching your solutions with mine. So let's say here -1, 5. So I'm at the origin here. I'm starting at the origin here. So -1, 5. So that's going to be -1 to my left, and say here 1, 2, 3, 4, 5 upwards. So I'm going to be at this position here, and I'm going to call this position here, say, A. Next one here is 2, -2. So I'm going to go in the direction here, 1, 2. Then I'm going to go, say here, down 2, 1, 2. That's going to be in this position, say here. Okay, and then of course we're going to be going ahead then, and we're going to be plotting the point -3, -1. So that's going to be, say here, 1, 2, 3, and we're going to go down 1, 1, right in this position here. So this is going to be my point B, and this is going to be my point C. And just remember that that point in the middle here is my origin. Let's just remove it just in case it may be a bit confusing for some of you guys. Okay, that's just my origin. Okay, so then I'm going to go ahead then and connect, say here, A to, say here, B. Then I'm going to connect point C to point B. Then I'm going to, of course, connect point A then to point C. And so it forms this triangle. All right, now we're going to be reflecting it through these lines. Now before I actually get into what these lines are, I must mention something very important, because occasionally, sometimes if the student is not told something, it can really be misleading. Now it begs to also mention, let me just make a note of this in red, that the y-axis actually has an equation. And so the equation of the y-axis is going to be x equal 0. So why is the y-axis has the equation x equals 0? And then of course, why does the x-axis have the equation y equals 0? Because of course, with this vertical line here, which is our y-axis, it is actually crossing the x-axis exactly at 0. Okay, so that's why we're saying that the y-axis has the equation x equals 0. So occasionally you will find sometimes that, as opposed to the examination saying to you that you need to reflect the object across the x-axis, they will say reflect the object across the line y equals 0. Or you might find where they say reflect the object across the, as opposed to saying reflect the object across the y-axis, they will say instead of saying reflect the object across the x-axis, they will instead say in the question reflect it across the line y equal 0. So it really does beg to actually remember that we have the y-axis being labeled x equals 0 and the x-axis being labeled y equals 0. This is key information, guys, that you don't find many students being taught. All right, so I just want to make mention of that. All right, so yes, so basically then the y-axis crosses the x-axis at 0, and then similarly the x-axis basically will in fact cross the y-axis at 0. All right, beautiful. So therefore then we're looking at reflecting this particular shape across the line. First here we're going to be looking at reflecting it across the line x equals 3. Now what this means is that I'm going to be locating the value 3 on the x-axis. So here we're looking at 1, 2, 3. This is number 3 on the x-axis. So we're going to go ahead then and we're going to draw, say here, this pink line. We're going to extend it all the way down. Okay, let's just zoom up here. We're going to extend it all the way down. Let me just erase it here. I particularly like drawing these types of lines broken because they are imaginary. Okay, so we are the one that actually placed it on the graph. So that is the line of reflection. And so there's not a formula that you can safely say that, oh, the x is going to change and the y is going to remain. That rule only applies if the reflection occurs across the standard mirror lines. But when the mirror line has been translated, then the mirror line y-axis has been moved to, say here, x equal 1 or x equal 2 or x equal 3, like in this example, then you're going to find then that you're going to have to use what is called the equidistance method. So the equidistance method is what we demonstrated at the beginning of this video, where we're going to be looking at how far are the vertices on the object is away from the mirror line. So therefore then if we look closely here, you'll realize that, say here, A is in fact 1. Okay, pardon me here, guys. So we're going to be looking at, say here, A is in fact 1, 2, 3, 4. Let's not do that. This makes it a little bit untidy. So let's just focus here, guys. From A going towards this pink line here is 1, 2, 3, 4 units on the left side. So automatically it's going to be, say here, 1, 2, 3, 4 units on the right side here. So that's going to be, say here, my A prime. And so then C as well here is going to be, say here, let's count, 1, 2, 3, 4, 5, 6 units on the left side of that pink mirror line. Then it's going to be, say here, 1, 2, 3, 4, 5, 6 on the right side. That's going to be my C prime. And then of course B is a mere 1 unit away from that mirror line. So B prime is going to be 1 unit on the other side here. Let's just erase this B from here and let's just rewrite it on the other side here so it doesn't interfere with our plotting. And so therefore then we can easily then label this point here, say B prime. And so easily then I can therefore then connect, say here, A prime to B prime. Then we're going to connect, say here, A prime to C prime. And then we're going to connect here, B prime, say here to C prime. Beautiful. And that there forms our non-standard reflection across the line x equal 3. Let us label this line here x equal 3. All right, that means it's passed into 3 on the x axis. All right, again guys, do not forget to hit the like button. It really does help the channel to grow. Already you're getting some value, I think, so do not forget to hit the like button before you exit this video. So we're about 45 minutes in and we still have much to do. So let's just continue here. We're going to then reflect that very same object then, but this time we're going to reflect it across the line y equal -2. Now, if my diagram gets a little bit crowded, I'm just going to erase the pink one, but I'm going to try to use some colors here for you guys to show you the indifference between the points. So here then, I'm going to be reflecting it across the line y equal -2. So here, I'm going to zoom up here, and then we're looking at, say here, going across 2 in the y-axis. So -2 here, that's -1 on the y-axis here, and -2 here. I'm just going to basically draw with green line here, this. So hope it doesn't get too confusing for you guys. Just keep your eyes. If you guys want to do this, you can pull up a different graph paper, okay? And you can redraw your x and y axis and do a fresh graph. But I have the colors here, so just pay attention to the colors, guys. All right, so therefore then we're looking beautifully there at that line. Let's just label it here, y equal -2. And so then we're going to be reflecting this particular shape here across this line. So obviously it is above the green line, so after the reflection it should perhaps be below the green line. So let's say here, all right, same procedure. C is in fact going to be, say here, 1 unit, a mere 1 unit above the green line. So C prime is going to be, say here, 1 unit below the green line here. B here is in fact on the mirror line. So let's just label this point here B. B is known as an invariant point. It's known as an invariant point because after the reflection then it did not move. It remained on the line. So therefore we're just going to label this right here again here. Say here B prime. So it's an invariant point. All right. So a few of my students will have already known this information. Most likely you're not going to really hear us talking about invariant points at the Csec level, but at the higher level you're going to hear about invariant point. And then of course naturally then A here all the way up here is going to be 1 2 3 4 5 6 7 points or 7 units above the green line. So it's going to be 1 2 3 4 5. See here, let's go again. In this line here, this is A here. So 1 2 3 4 5 6. Aha, 7. We just made it. We're just at the end of our graph here, and that's going to be my A prime here. And then of course naturally then I'm just going to connect, say here, C prime, all right, say here to A prime, and then we're going to connect, say here, B prime, C prime to B prime, and then I'll naturally then finish this off by connecting B prime, say here, to A prime. And so we have that beautiful reflection here across the line y equal -2. All right, beautiful. So looks as if my graph is a little bit crowded now, guys, so I may have to erase this. Let us try to see if we can actually do another one. Remember that for exam purposes you're not going to get 3 reflections or 2 reflections. The most you might get is 2 reflections or a combination of any 2 transformations, but it's not going to be very crowded like this. All right, this is just because I'm actually going through the theoretical aspect application of transformation geometry. Let us see if it's going to become crowded. I'm going to be using a yellow line here. So here then we're looking at, say here, looking at x equal -2. So x equal -2 is going to be naturally then, aha, let's just do it here. This is the x-axis here, this horizontal line. So this is 1, this is 2. So we're going to be, this is going to be our line of reflection. Okay, and then we're going to come down here. All right, so definitely, most certainly, guys, I'm going to have to erase the whole entire diagram for the last one. So let's keep our eyes, guys, on the yellow line. Keep our eyes on the yellow line here. So therefore, then we're going to be reflecting A. Now, this is a perfect example where basically the mirror line runs through a section of our shape. All right, and sometimes this can be a little bit tricky for students because they sometimes have a pre-notion that the object and the image should not overlap. There is no rule out there that says that the object and the image cannot overlap. It really depends on where the mirror line actually is. So in this case here, the mirror line actually runs through a section of our object here. And so what we're looking at then is, in fact, same procedure. How far is A from the mirror line? Yellow. So it is a mere 1 unit away. So therefore it's going to be 1 unit on the other side. So that's going to be my A prime. And then of course C is on the left side of the mirror line here. So it's again a mere 1 unit away. So another 1 unit away here. That's going to be C prime. All right, keep your eyes, guys, on the yellow line and the yellow points. All right, I know it's a little bit confusing, but I'm keeping everything here on one graph so you can see a very good comparison. And then of course we find out that B, this invariant point from the previous question here, it is going to be, carefully guys, 1, 2, 3, 4 units away from the yellow line. So it's, again, let's count from B here, 1, 2, 3, 4 units away from the yellow line, because that's our line of reflection. So it's going to be 1, 2, 3, 4 units on the other side, and that's going to be my, say here, B prime. All right, for the yellow line. So of course then I'm going to go ahead and connect A prime to, say here, C prime, and then we're going to connect B prime here to, say here, A prime, and then finally then we're going to connect, say here, B prime here to C prime. All right, and that's basically the yellow now becomes a reflection of the white here, if that was our basic reflection. All right, definitely way too crowded for the last one, so hopefully you guys got that. Remember that if a point remains on the line of reflection, it is called an invariant point. All right, so let's just give this a big erase, a big wipe here. Make sure that you guys already would have had a screenshot of all that we have done so far. Okay, we're gonna have to replot my object point here just for the last one. So I'm gonna go ahead then and get back to my white marker, and then I'm gonna replot my point, -1, 5. So that's -1 up 5, 1, 2, 3, 4, 5. That's going to be my original A here, and then B is in fact 2, -2. So that's 1, 2, 1, 2. That's down here. That's my original point. Okay, let's just fix this. And then C then is going to be -3, 1. So that's -3, -1, pardon me. 1, 2, 3, 1 down here. Okay, and that's my C prime. All right, let's just reconnect here with here with here, and that's for the final non-standard reflection. All right, or we're gonna call it a reflection of a line that is parallel to the x-axis or the y-axis. So y equal 1. So let's do, say here, oh, did we use a blue? I don't think we used a blue. Okay, so keep it color coded. Y equal 1. Now again is an example here. Here's y equal 1. I'm going to be running this blue line here through, say here, 1 unit above the x-axis. So it goes through 1 on the y-axis, which is 1 unit above the x-axis. Okay, see here beautifully. All right, I think we should use a different color blue. So this one's a little bit dark, so let's just use this brighter one here. Let's just erase all of this. Whoops, pardon me guys. Okay, just do this here, keep it clean. All right, beautiful. So let's just make this brighter one here. Okay, so line y equal 1, and this is another perfect example of where the reflection line runs through our object. So this bottom half up here is this bottom half here is going to go flip up to the top, and then this top half here is going to flip down to the bottom. All right, and again, that all comes down to you checking the units of the object away from the mirror line. Let's start off with A here. A is a mere 1, 2, 3, 4 units away from the blue line, so it's going to be 1, 2, 3, 4 units below the mirror line here. So that's going to be my, again, A prime. B prime now is again below the mirror line, so it's going to be above. Okay, so B is going to be 1, 2, 3 above the blue line, sorry, below the blue line. So it's going to be 1, 2, 3 above this, say here, blue line. That is B prime. Okay, I think I made a mistake here by labeling these white ones here primes, so I don't think that was correct. All right, and then finally then we're looking at C, which is a mere 2 units below the mirror line. So that's 1, 2, so it's going to be 2 units above here. Okay, and so that's going to be my C prime. And so by connecting here, you find that there is a flip. Okay, and let's go down here and connect. Just be careful when you're plotting and just stay focused, guys, because sometimes it can really get a little confusing, especially if you're a student that finds math challenging. So you've just got to take your time and focus. And that there beautifully is a reflection across the line. See here, y equals 1. All right, now you're going to find also later on that sometimes if it is that you are given a question with the object and the image already drawn for you, recognizing sometimes the type of reflection can be tricky, because sometimes, most times, what you're going to find that in your instructional classes, you'll find that a lot of emphasis is placed on the standard reflections, x-axis, y-axis, y equal x, y equal negative x, and then of course on examinations you might get a question where the reflection is non-standard. So not all reflections are going to be standard, some reflections are going to be non-standard. It really boils down to the amount of practice that you put outside of the class, all right? But you can use that equidistance method of determining whether or not your object and your image is across a standard line or a non-standard mirror line. All right, so hopefully you guys got some really nice value from that section of the video. Let us proceed then to looking at some more important aspects then. So all of that there was just standard reflection without a formula, non-standard reflection without a formula. But of course we cannot leave out the formula, guys. So let's dive on right into, say here, standard reflections and acquiring the metric. All right, we have already looked at how to develop the metric, so we are already ahead of time here. Let's look at, say here, a reflection across the x-axis. Now let's read here. It says this suggests that if an object undergoes this reflection, we said it earlier, that the sign of the x coordinate value will remain the same, and the sign is going to, the sign of the x ordinate is going to remain the same, but the sign of the y ordinate value will change. That is, say here, a random point xy will eventually, after the reflection, become x negative y. We already looked at that. So therefore then already we can safely say that this here is how many x's? 1. How many y's? Negative 1. How many x's at the, pardon me, that's incorrect. At the top here, x. How many x's? 1. How many y's here? None. On this side here, how many x's? None. How many y's? Negative 1. All right, so I'm just going to quickly just kind of run through this here. For the y-axis is going to be, say here, easily xy, all right, gets reflected and it becomes negative x, y, okay, and then easily then that becomes negative 1, 0, 0, 1, okay, and then down here we're going to have reflection in the line y equal x, so we have xy, random point, gets reflected across the line y equals x will interchange position. Therefore, we end up with a reflection metric here, say 0, 0, x and 1y, and at the bottom 1x and 0y. Okay, and of course finally then we end up with, say here, y equal -x, where we have a random point xy was sent through this line of reflection, then becomes a flip of the interchange of the points and a change in the signs. So therefore then easily this becomes, say here, 0, -1, -1, say here 0. All right, so I have them here in red. Let us focus on what actually changed. We can find many unique ways of remembering it. It really depends on you as a student. So for me personally, I always tell myself, if it reflects in the x will remain, so automatically the y will change. If it reflects in the y, then the y will remain and the x will change. So whatever the line of reflection is, that one is going to remain the same, and then obviously the other one is going to change. For the last two, we know that there's going to be an interchange in the points, but I have to try to remember which one has a change in signs and which one doesn't. So of course the positive one, y equal x, just has the interchange in the position, and the line y equal -x has an interchange as well as a change in the signs. So you can find your own unique ways to remember the matrix or remember the change. It really boils down to you as a student. All right, so we are an hour into this particular video here. I'm gonna be ending this part of the tutorial here. I'm going to be creating a part 2 for reflection here, so we're going to get into the actual calculation, because we are about an hour in. So I know that this is a lot of information to process. You can definitely take a break and then you can come back to part 2, which you're going to be uploading in just a few hours from this one, and you can click on that and dive on into the more calculation aspect, the more exam approach towards this, because it's all well and good when you know the change, but sometimes they will ask you to show the calculation or use a metric method. So we're going to dive off into that. All right, and then we're going to be looking at also the properties of the reflection, how to identify a reflection, so on and so forth. All right, so there's much to discuss in part 2, inverse reflection, so on and so forth. All right, so I want to thank you guys so much again for staying tuned here for an hour with me. Do hope that you enjoyed the content, and of course you got the clarity that you need for reflection. So until next time, take care. My name is Akin, your math instructor. Do not forget to hit the subscribe button below, turn on your post notification bell, leave your thoughts and comments down below, and do not forget to share this out to your math communities and friends. All right, let's get ready to ace the transformation exam. Until then, take care.